Have you ever wondered how the digital world structures and presents its vast amounts of information? The secret lies in markup languages. These clever systems are designed to describe and structure documents, using tags or codes embedded in the text to define elements. These elements can represent structural components, formatting, or even semantic meaning. The key components of markup languages are tags or elements, attributes, and content. Tags, enclosed in angle brackets, define the beginning and end of elements. Attributes provide additional information about elements and are specified within the opening tag. Finally, the content is the actual text or data enclosed by the tags. Popular markup languages include HTML, XML, SGML, and Markdown, each with its own unique uses and benefits. In essence, markup languages are the backbone of our digital world, providing structure and meaning to raw data. The journey of markup languages starts with SGML, the grandparent of all markup languages, which came into existence in the 1980s. Standard Generalized Markup Language, or SGML, was the first to provide a structured way to represent information in a document. It was comprehensive, allowing for the definition of document types, but its complexity was a barrier to widespread adoption. Coming onto the scene in the early 90s, HTML, short for Hypertext Markup Language, was an offshoot of SGML. HTML was designed specifically for the web, providing a simpler way to structure and format web content. It uses tags to define elements like headings, paragraphs, links, and multimedia elements. HTML made it possible to create the rich, interactive web pages we're familiar with today and remains a cornerstone of web development. As the internet evolved, so did the need for a more flexible markup language. Enter XML, or Extensible Markup Language. In the late 90s, XML took the best of SGML and HTML, the structure and the simplicity, and added a new level of flexibility. Unlike HTML, XML allows users to define their own tags and document structures. This made XML ideal for data interchange, configuration files, and representing hierarchical data. But the evolution didn't stop there. With the advent of social media and other platforms that required quick, simple text formatting, a new kind of markup language was needed. That's when Markdown was introduced in the early 2000s. Markdown is a lightweight markup language that made it easy to format plain text. It's commonly used for creating documentation and readme files, with its simplicity making it a favorite among developers. So from the comprehensive but complex SGML to the simple and straightforward Markdown, the evolution of markup languages has been a journey of adaptation and improvement. As technology and the digital landscape continue to change, who knows what the next evolution of markup languages will bring? As we moved from SGML to Markdown, markup languages became more user-friendly and versatile, adapting to the changing needs of the digital world. Among these markup languages, XML stands out for its flexibility and extensibility. Born from the need for a standardized way of encoding documents that are both human-readable and machine-readable, XML, or Extensible Markup Language, has been a game-changer. Its syntax, while simple, is incredibly powerful. Comprised of opening and closing tags, attributes, and text content, XML allows for clear and structured representation of data. Remember though, XML is case-sensitive. So a book tag is not the same as a book tag, but what sets XML apart is its extensibility. Users have the freedom to define their own tags and document structures. This flexibility is what makes XML so adaptable to a myriad of applications. You're not confined to a predefined set of tags, as you would be with HTML. You can create an XML document to represent a book, a car, or even the solar system. The possibilities are endless. XML is widely used for data interchange, acting as a common language that different systems can understand. It's also commonly found in configuration files, where it represents hierarchical data in a structured, readable format. Let's take a quick look at a simple XML document to see these concepts in action. Imagine a book element, with nested elements for title, author, and published. Each of these elements is defined by opening and closing tags, with the content sandwiched in between. So, our book element might look something like this. Open angle bracket, book, close angle bracket. Nested within, we have title, with introduction to XML, author with John Doe, and published with 2022. Then we close it off with an end book tag. And there you have it. A simple XML document that represents a book, readable by both humans and machines. XML's ability to define custom tags and structures made it a popular choice for data interchange and configuration files. It's an example of how markup languages have evolved to meet the complex needs of our digital world. Opening. The applications of markup languages are as diverse as the digital world itself. Let's dive into the various use cases of markup languages. One of the most common applications is in web development. HTML, or hypertext markup language, is the backbone of the web, structuring web pages and presenting content. It's like the skeleton of a website, defining headings, paragraphs, links, and multimedia elements. But the reach of markup languages extends beyond the web. They're integral to data interchange. XML, or eXtensible markup language, is a popular choice for representing and exchanging structured data between different systems. Its flexibility and extensibility allow users to define their own tags and document structures. Think about it. When you're logging into a mobile app, XML might be quietly working behind the scenes, facilitating the exchange of user data between the app on your phone and the server. Markup languages also play a crucial role in documentation. Markdown, a lightweight markup language, is commonly used for formatting plain text. It's often used for creating documentation and README files that guide users and developers. With its simple syntax, Markdown makes it easy to add formatting elements like headers, links, and lists to plain text. Finally, let's talk about configuration files. Markup languages are often used for configuring software and applications. XML, for example, is commonly used to store and transport data in configuration files. This way, software applications can read these configuration files to know how to operate or how to present certain information. From structuring web pages to configuring software, markup languages play a critical role in various aspects of the digital world. They're the silent workhorses powering our digital experiences, from browsing the web to using mobile apps. They help to streamline data interchange, simplify documentation, and enable software configuration. Ending. From structuring web pages to configuring software, markup languages play a critical role in various aspects of the digital world. Like any technology, markup languages come with their own set of pros and cons. Let's delve into them. First up, the advantages. One of the major strengths of markup languages is their human readability. Designed to be easily understood by both humans and machines, they provide a clear, structured way to represent and structure information. This makes them ideal for a range of applications, from web development to data interchange. Another important advantage is the structure they provide. By using tags to define different elements, markup languages allow for highly organized and structured documents. This structure makes it easier to understand and manipulate the data contained within the documents. Lastly, the extensibility of markup languages is a key benefit. With languages like XML, users have the freedom to create their own tags and document structures. This means they can tailor the language to their specific needs, adding a level of flexibility that's hard to match. But like all things, markup languages do have their limitations. One such drawback is verbosity. Some markup languages, including XML, can be quite wordy. This verbosity can lead to larger file sizes, which might be a concern in certain applications. Another limitation is the learning curve. While markup languages are designed to be human-readable, learning their syntax and rules can require some effort. This might be a hurdle for beginners or those not familiar with coding. However, it's important to remember that these limitations are largely outweighed by the benefits. The verbosity issue can be mitigated with data compression techniques, and the learning curve is often a one-time investment that pays off in the long run. So there you have it. Markup languages, with their human readability, structure, and extensibility, offer immense benefits. And while they do have their limitations, these are minor in comparison to the vast capabilities they offer. Despite their limitations, the benefits of markup languages far outweigh their drawbacks, making them indispensable in the digital world. To wrap it up, markup languages have revolutionized the way we structure and present information in the digital world. They are the backbone of digital content, providing a structured, human and machine-readable method of defining and presenting data. From the comprehensive SGML, the ever-popular HTML, to the extensible XML, each markup language has its unique characteristics and applications. XML, in particular with its flexibility and user-defined structure, has found wide-ranging applications from data interchange to configuration files. These languages have their strengths, like readability and structure, but they also have their limitations, such as verbosity and a learning curve. But despite these limitations, the importance of markup languages in our digital world remains undiminished. Whether you're a web developer, a data analyst, or just a curious individual, understanding markup languages can open up a new world of possibilities, so dive in and explore.